Next section is remainder theorem. Statement is this: let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. P of x is a polynomial of degree greater than 1 and a be a real number. If p of x is divided by the linear polynomial x minus a, the remainder is p of a. You have to by heart this statement. So, using this theorem we can find the remainder. If they are asking you to find using the long division, then only you have to go for that. Otherwise, you have to go for this using remainder theorem. So, example 9, find the remainder when x raised to 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1. Here the polynomial given is, let f of x is equal to x raised to 4 plus x cube minus 2x square plus x plus 1. This is the given polynomial. The linear polynomial given is x minus 1. We have to find the remainder. So, using the remainder theorem, the remainder is f of 1. F of 1 is a remainder. So, remainder is equal to f of 1 because it is of the form x minus a. Instead of a, they have given the value 1. So, the remainder is actually f of a. Here we can find the remainder by substituting a as 1. That means f of 1. So, it is equal to 1 raised to 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. So, it is 1 plus 1 minus 2 plus 2. So, the answer is 2 using remainder theorem. You have to mention that. So, here the remainder is 2. Next, exercise 2.3, first question. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x. So, let us suppose f of x is equal to x cube plus 3x square plus 3x plus 1. The linear polynomial given is x, which we can write as g of x is equal to the linear polynomial as x minus 0. We can write x as x minus 0. So, what you have to find is the remainder. What is the remainder then? F of 0 is the remainder. Remainder is equal to f of 0, which is equal to 0 plus 0 plus 0 plus 1, which is equal to 1. So, using the remainder theorem, remainder is equal to f of 0, which we got as 1. Then next, fifth subdivision, in which the linear polynomial is given as 5 plus 2x, but we should get in the form x minus a. For this, we have to write this as 2x plus 5. We need to make the coefficient 1. For that, we are taking out this 2. So, x plus 5 by 2, which we can write as 2 into x minus 5 by 2, because we should get in the form x minus a. So, this is a linear polynomial. The linear polynomial is this. So, x minus 5 by 2, that is a linear polynomial. So, the remainder is f of minus 5 by 2. The remainder is equal to f of minus 5 by 2. So, we have to replace x by minus 5 by 2. So, minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1, which is equal to minus 125 divided by 8 plus 75 divided by 4 minus 15 divided by 2 plus 1, which is equal to minus 27 by 8. This is the remainder obtained when this polynomial is divided by 2x plus 5. Next is example 10. Check whether the polynomial q of t 4tq plus 4t square minus t minus 1 is a multiple of 2t plus 1. If 2t plus 1 is a multiple of q of t, then the remainder will be 0. So, if the remainder is 0, we can say it is a multiple of q of t is a multiple of 2t plus 1. So, we can say if the remainder is 0, we can say q of t is a multiple of 2t plus 1, or in other words we can say 2t plus 1 is a factor of q of t. Both are same. Either you can say q of t is a multiple of 2t plus 1, or you can say 2t plus 1 is a factor of q of t. So, remainder should be equal to 0. That is what we have to check whether this polynomial is a multiple of 2t plus 1. So, clearly q of t is given 4t cube plus 4t square minus t minus 1, and the linear polynomial is 2t plus 1. We have to get in the form x minus a. Take out 2, so t plus 1 by 2, which is equal to 2 into t minus 1 by 2. This is the linear polynomial. So, we have to find the remainder. Remainder is equal to q of minus 1 by 2, which is equal to 4 into minus 1 by 2 whole cube plus 4 into minus 1 by 2 whole square minus 1 by 2 minus 1. Which is equal to 4 into minus 1 by 8 plus 4 into 1 by 4 plus 1 by 2 minus 1. So, which is equal to minus 1 by 2 plus 1 by 2 minus 1. Clearly, this is equal to 0. So, remainder is 0. Therefore, what we can write as q of t is a multiple of two t plus 1. This is the final answer. What we have proved is remainder equal to 0. Since remainder is equal to 0, we can say q of t is a multiple of 2t plus 1, or other words 2t plus 1 is a factor of q of t. Then exercise 2.3, second question. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. So, we can take let f of x is equal to x cube minus ax square plus 6x minus a, and the linear polynomial given us x minus a. So, remainder is equal to f of a using remainder theorem. So, it is equal to, replace all the x by a. So, a cube minus a into a square plus 6 into a minus a, which is equal to a cube minus a cube plus 6a minus a. We can cancel these two. Remaining is 5a. This is the remainder obtained. Third question. Check whether 7 plus 3x is a factor of 3x cube plus 7x. We have already done similar, but what I want to explain is 7 plus 3x is a factor of this, or other words, this is a multiple of 7 plus 3x. So what you have to check is whether the remainder equal to 0, which you can do as homework. If the remainder is 0, we can say 7 plus 3x is a factor of 3x cube plus 7x. Some extra questions. First question, if minus 4 is the 0 of p of x is equal to x square plus 11x plus k, then calculate the value of k. What is given is minus 4 is a 0 of this. So what is given is p of x. P of x is equal to x square plus 11x plus k. Minus 4 is a 0 of this polynomial means p of minus 4 equal to 0. Since minus 4 is a 0 of p of x, p of minus 4 equal to 0. P of minus 4 equal to 0 means minus 4 whole square plus 11 into minus 4 plus k equal to 0. That means 16 minus 44 plus k equal to 0. That is equal to minus 28. Minus 28 plus k equal to 0. So k is equal to 28. This is the answer. What is given as minus 4 is a 0 of p of x is equal to x square plus 11x plus k. We have to find the value of this unknown k. So minus 4 is a 0 means p of minus 4 equal to 0. So substituting minus 4 instead of x, we are getting k as 28. Then write the maximum number of zeros of the polynomial. Number of zeros. If the polynomial is a linear polynomial, 1 0. Polynomial is a quadratic polynomial, 2 zeros. Cubic polynomial, 3 zeros and so on. Here what is given is p of y is equal to m y raised to a. Zeros depends on this. So number of zeros is equal to a. Then third question, write the coefficient of x in the expression x square plus pi by 2x minus 7. Coefficient you have learned last year. So coefficient of x means excluding this x, whatever is remaining, that is the coefficient. So it is equal to pi by 2. Pi by 2 is the coefficient of x. Then homework. If x raised to 11 plus 101 is divided by x plus 1, then find the remainder. This polynomial is divided by a linear polynomial. You have to find the remainder using f of a. Then exercise 2.3, first question, first, second and fourth subdivisions.